I will start only at 55. So I need you to have the slide ready and audio ready before I stream.
Already started recording?
Sure.
Danny is here.
I can share my screen already, Vic. Please start the streaming.
Okay, you share first before I stream. Share with audio.
Hi, Danny.
Hello.
Hello.
So short right now.
Sorry.
You're having sore throat.
No, I'm not. It's just that I said I'll join this and listen in.
Okay.
Instead of coming in through YouTube Live.
You want me to go through the other side?
No. You're welcome to stay here. No problem.
I'm
Alright.
going to start streaming now. Once Noel's slide is ready up, then I'll start stream.
Okay. By the way, my email is not syncing yet. There are too many things on the network, right? My PowerPoint that I tried to open up on the other side, it looks like half the files are all hung because they are not on my machine. I don't know how the heck it got out to the SharePoint, but anyway, it is what it is. I'm just going to blur my background because my email is not coming in. I'm just going to share my screen.
Actually, in the team chat, there's call already shared the slide, the background. You go into the chat.
Hold on, let's see. Teams chat.
This current one. Yeah. I'll send it there.
I don't see the picture. It's just one dark gray patch. Here it is. Let's see. Section 17.
Section 17, right? It's a small wet market. Is this the one? Can you see? No, right? No. It's section 17. What's the layers location there? I think what's on there, I know. You know any landmark there?
Grossman roundabout.
There's a flat, right? I know there's near the flat.
Come on, can I get this?
I think Noel is okay. Don't fix the virtual background blur is fine. Not a lot of effect. So let's start preparing because it's 12:58.
Can you guys see my slides now?
No, I haven't shared.
I'm starting my session soon.
Noel, your audio is very bad. Are you using Jabra or?
I think it's a USB port on this laptop. Cole, you have my slides? Can you share your screen?
I don't have your letters.
Go to the SharePoint and download it. It's version 1.2.
Okay.
Thanks.
1 minute to 1 p.m. I need to start streaming soon.
Stream now. Now, listen. Stream now. Just stream it. Even though it's blank, it's okay. Stream it. That's what Germany does. They stream for half an hour with nothing. They just hear people talking and so forth. That's how they do. That's what Michelle asked us to do. Just stream it. Don't worry. Then on the dot, then we show the slides. Yeah. Switch the slide in there.
Okay, we have started streaming.
Awesome. Thank you. Thank you, Ray.
Yeah, it's
Downloading.
streaming already.
Can you share your screen, Cole?
Not yet, not
Once you
yet.
got-
Downloading, downloading. 1.2, right?
Yeah. Can you guys ping whoever? Let them know that we are having some technical problems. My machine this time. Let's see whether we can do it without. Oh, is your thing working now?
Downloading.
Wait, do you have the slide deck with you?
I have version 1.1. Okay, done.
Okay, just share your screen and. We'll be starting in a minute. Apologies for the technical problem. Okay, here we go. Thank you everyone for joining us for this Tech Talks. Right, it's been a few weeks since we had this, and welcome. A good morning, good afternoon, good evening, wherever you may be. All right, let's get started. Thank you, Cole. Thank you for helping me with this. All right, let's go to the next slide. Many of you joined us last year, right? And we had 3 exciting sessions in December, right? And of course, that gave us a start to a momentum that we felt that we have to continue to keep going, right? In January this year, we started to talk about what we can do for the year 2023, right? So let's see what we have in store for this year. Thank you, Cole. Right, as you can see, we have an exciting lineup. This time around, we're going to use the last Monday of each month from 1 p.m. to 2 p.m. to get us going, right? So that we are able to excite you, right? Like the first session, for example, right? In session 1, designing the fastest and most reliable HCI with Azure Stack HCI. So in this session, we're actually going to run through in-depth understanding of the architecture. All right, let's keep going. Now, like the spirit of all our previous Tech Talks, we believe that this is an opportunity for us to inspire you. But more importantly, apart from inspiring you, we also wanted to ignite this flame in your heart and in your mind so that you'll be able to take off, all right? And take off where? With a 3-2-1 momentum, if you want, take off in your career. For those of you who are connecting and understanding the technology in your jobs, but even for our partners, who are currently going through their journey with Azure HCI and even Windows Server. We want you to take off in ways to build your business, even at a time such as this. Next. My name is Noel, all right, and more importantly is the team that I have together with me, who's going to take you through this session, all right? Cole, Vic, Lorraine, three of the key members that I have with me, right? Cole will help us with a lot of the demos, and of course, behind the scene, we have Vic and we have Lorraine, all right, making sure that this session is successful, right? There's no way I can do this alone, right? Just like what we're talking about. But very importantly, in this particular session, we have an exciting agenda in store for you, right? In the first part of it, we wanted to bring together the design elements. And these design elements are made up of two primary components that give us powerful, right, performance and reliability capability within this solution, right? And number two, we wanted to ensure that you understand how these components come together to give you and satisfy your need for speed. So very importantly, we wanted you to know that this solution has the power of the highest performance. Number three, we believe that whenever we expect our customers to put their most mission critical into the solution, we promise reliability of the highest level. And therefore, we will encapsulate the resiliency within this session. And the other aspect that is very important to ensure the high availability of the solution is to ensure that the system is well managed. So patch management is the other aspect. Last but not least, we believe that the built-in disaster readiness capability for high availability is very important. And for the overall, if you want, health and resiliency of the service that IT provides to the users. So these five components, if you want, is going to dominate the rest of the session. Next call. Thank you. Now, those of you, regardless of whether you're coming in from YouTube Live or you're coming in through these team sessions, right? Performance and resiliency obviously are two major components. But many of our time, our customers will come to us and tell us, this is the capacity or the amount of data that I want to be able to store into the solution, right? And therefore, these parts make up the triangle, if you want, in terms of customer needs. Click. The next other portion, which I felt that makes up one of the quadrants, is affordability. Now, what does affordability mean? Affordability means that this solution must be able to fit within the budget of the customer. So everything from the total cost of ownership and even the return on investment must make sense from a customer perspective. So that's where affordability comes into the picture. In a time such as this, Microsoft believes that do more with less is going to be too hard to bring a solution like this into the midst of the customer. Okay, next. Now, many of you know that this particular session is pretty much orchestrated through the Microsoft Hybrid User Group. So you see the QR code there on the right. All right, I'd like you to click on that so that you can join us in this group, so that you can continue to be updated with all the latest and greatest sharing that we have. I know between Cole, myself, Vic, and even Lorraine and the rest, continue to share a rich amount of information regarding the Azure Hybrid capabilities of Microsoft. And despite that, all right, we believe that there are many other additional capabilities that's going to enrich this solution, like AI, for example. So some of those areas will also come into this particular group. Click. Some of you may have seen this in the previous session that we did, but we're very proud to bring you Gartner's finding, right, through this voice of customer PI, if you want. Now, what's so significant about this voice of customer truly is customers of Microsoft coming forward to say how excited they are about technology and how they're willing to speak on behalf. So as Cole goes to the next slide, you will discover that even in Asia Pacific, there are as high as 46% of customers are willing to step forward. Now, 99% says they're willing to recommend. I think this speaks volume into how Microsoft has made an impact to customers and their mission criticality of their data through a solution called Azure Stack HCI. Okay. Now, some of you have already started to dabble on this solution. There are two different ways you can deploy. One is called integrated systems and the other called validated nodes. Regardless of which one, you will be able to run a whole flurry of Windows virtual machines from a VDI perspective. You'll be able to run Windows Server virtual machines, consolidating them across, and even Linux virtual machines. So the guest OS is rich with all of these solutions managed by a solution called Windows Admin Center. So this solution brings together the starting point of a highly virtualized, highly dense HCI solution for your customers, running VMs on all their servers for their premise. But not limited to that, we can also do more than that. Right? True? Yep. We can even run Azure PaaS services like Azure Kubernetes Service, Azure Virtual Desktop, all those in preview, right? A richness of all these PaaS services brings together capabilities that customers, regardless of what their situation is, whether they are in the work from home, work from anywhere situation, or even if you want, those who are starting to bring down services back to an on-prem setting. So it's very important for us to understand that many of these services, including those available on Azure, can now be run down in an on-prem environment. Next. Now, in May last year, some of you may have seen this announcement talking about Azure Stack HCI running in a single node. It's very exciting to know that the smallest of requirements has not been forgotten by Microsoft. So customers who want to run edge deployment around the nation and in around remote locations are now able to do that with the single node deployment. Thank you. Next, please. Some customers also came forward and say, you know what, I would like it to be able to integrate with cloud. So it's not surprising that a single node has integration with Azure Arc, right? And you can even manage it from the Azure portal through a Windows Admin Center that is available from the Azure portal. So it's very exciting that not limited to billing, right? How much the customer needs to pay, but even how you manage it entirely end-to-end can be done through the cloud. So customers who have made the journey to the cloud have not been forgotten in this single node deployment. Because many time that in remote locations, right, they could be cost sensitivity for one, it could be latency, it could be just that those environments do not yet have a data center-like infrastructure. So there are many, many reasons for customers of all sizes, whether they're from the SMB or they're from the mid-market or the large enterprise. They now can enjoy a software-defined solution that originated from Azure, if you want. Next. So that's it. We felt that it's important for us to share with you how the technology works. I'm going to get Cole now to show you how even in a single node, it can solve failure without bringing down the solution. So this is a first baby step, but a very powerful step to resiliency solution. Cool. Thank you.
Thanks. Can you see the screen?
Yes.
Awesome. Thanks everyone. I'm Cole, a technology specialist from IDSC. All right. So thanks now on the sharing about the GA of the single node cluster since last year, May, right, where Azure Stack HCI start to support for single node cluster and is designed for edge environment, and yet have the capability to scale beyond, right? So let me walk you through a demo on what is the resiliency that actually supported even we run the workload in a single node configuration, right? So this is my single node cluster, right? And we actually use the Windows Admin Center to actually manage the cluster, right? From here, administrator can actually manage the entire cluster directly via these web browser tools, right? And from here, we can see that I have one node, right? One single node, right? And it's running on 32H2, which is the latest version. And from here, the administrator has a capability to actually manage the hard disk, right? The drive that is actually installed in the server, right? And also the volume, right? For example, now I have one volume created, which is volume 1, running on two-way mirror. And administrator can also use the tools to actually manage the virtual machine. Like for example, right, the workload that's running on top of this single node cluster, right? And also the server, the administrator can actually log in and interact with the virtual machine that is running, right? From here, I actually have a Linux machine running, and from here, I can actually use the Windows Admin Center to actually interact with the Linux virtual machine, right? This to prove that, right, the single node cluster not only capable to run the Windows virtual machine, right, it also capable to actually running Linux machine and allowing the administrator to actually interact with it, right, and manage it via the Windows Admin Center, right? So from here, I will do a simulation, right? My workload is running, my virtual machine is currently running. So I will simulate that there's this fail in the single node configuration, like for example, right, oh, there's something wrong with the hard disk, right? So one of the disks actually failed, right? So this definitely will happen in many scenarios during our production network. And this is what I want to bring up, where the scenario happened, the incident happened, right? How our workloads, right? How our virtual machine can actually still running, right? Even with this happen, right? So as you can see just now, I actually also that disable one of the disk, right? So this will actually reflect into this is my network environment where there's one drive fail, right? It's in lost communication, and only 3 are still running, right? So and after a couple of minutes, right, the Windows Admin Center will actually refresh with error message and warning saying that, oh, one of your drives is failed and your volume is not in healthy status. And if you go take a look on the volume, you'll see that my volume 1 is currently showing that need repair, and there's a lot of warning, red color warning, right, come out and alerting the administrator that, hey, there's drive fail and please do something with it, right? So, oh, there's drive fail. So what is going to be happen to my workload, right? So from here, we actually demonstrate that even with one drive fail in a single node configuration, right? My workload, right? The virtual machine are still up and running, right? And there's no downtime and there's no interference on the customer side where connecting to this particular workload, right? And of course, from here, administrator is managing the cluster as well as the node, right, directly from the Windows Admin Center. And from here, the administrator can actually have an overview that the drive that having issues, the virtual machine that is still running, right, and also the message, the alerts that actually show on the screen, right. So this is something that we'll see when the disk fail, right, and you see that there's one drive is actually lost communication, right. So we simulate the scenario where administrator have actually bought the new drive and he actually start to slot in the new drive to replace the faulty drive, right? So from here, because I'm running on the nested environment, so I will actually add a new drive into my virtual machine, right? Which is my single node cluster, right? So let me fast forward a little bit, right? This is just a drive adding process, right? So once the drive is added, right? So the drive will actually added into the storage pool, right? And let's refresh the screen for this Windows Admin Center. You'll see that the new drive is added into the screen, and it's currently still not in pool yet, right? Because the storage spaces dialect are still actually running in the background and try to synchronize all the drive, and it will actually add this drive into the storage pool, right? After a couple of minutes, right? So here we go. So here you can see that the new drive is added into the storage pool, and the old drive is currently marked as retired, and will actually remove from the storage pool after a couple of minutes later, after the synchronization process is completed, right? So let's take a look on our volume. It still shows as need repair, because it actually takes some time for the storage spaces direct mechanism and to actually run and synchronize all the storage, dry. Right. So from here you can see that the server still has some warning, right? Because the synchronization progress are still in progress. Right. You can see here, there's a warning. There's an indication saying that okay, the synchronization is still in progress, and it will take a couple of times. Right. So even with this, the drive fail, and in the middle of the administrator ordering or getting the new drive and slot in the new drive, and the synchronization is still in progress in the background, right? Our workloads, our virtual machine are still running, and there's no, so the customer and end user can actually still using the virtual machine and also the application running, right? So after a couple of minutes, you see that the retired drive is being removed from the storage space, storage pool, and the volume is back to its healthy status. So this is how, and what I wanted to show you about how the resiliency that provided for the Azure Stack HCI even is running on the single node configuration. All right, so that's all for me, and over to you now.
Thank you, Cole. Thank you. Yeah, as you bring back the slides, one of the discussions we had, remember when we started to show this capability a couple of months back, right? People came back to us and say, you know what? I think it's very important that we can tolerate drive failure. How about node failure? How are we going to handle this node failure of this single node? Now, sounds like mission impossible, isn't it? That you can handle node failure, all right? But really, if you dig deeper into their question, they are concerned about the availability of the application that the users are using, all right? So what were some of the things we spoke about, like SQL Server, for example, and so on, right? Maybe you can give us half a minute of what you think from an application perspective. You're muted. Cole, you're muted.
Yeah, no, I think it's very important for the customer perspective, right? Even the workload is down, and the customer even have a hybrid scenario where it can actually, like for example, the application is running on container, right? And even it's running on single node, right? And the database, the external database is actually connected to the SQL Server that is running on that particular single node. And on top of that, it can actually enable the hybrid scenario where it actually connected to the SQL Server managed instance that is actually running on Azure. Right. So this is a very powerful scenario where customer has a high, so-called a high ability capability, right? Even the solution is running on a single node configuration.
Fantastic. Yeah, totally agree. Yeah, I think the SQL Server 2022 that was released just a couple of weeks ago has the ability to synchronize its databases with the SQL managed instance on Azure. So truly, we have a powerful edge to cloud solution that gives us the ability. So as you can see, this comparison between the single node and multi-cloud, I guess the only setback, if you want, the only limitation is the stretch cluster, isn't it? Right. So being a single node, you cannot do stretch cluster. But apart from that, the single node is truly a very powerful solution, right? Okay, so let's move to the next slide. Now, as mentioned, right, the single node is not a weak solution, it's a powerful solution, even when customers are going down the path of containerization. So that's why Cole was talking about containerization, but containerization on its own is not enough if you cannot manage it. So Microsoft released a solution recently, right, called AKS Edge Essentials. It's the new name to AKS Lite, which was something that they mentioned later part of last year. But truly, this is a solution that I think we can be very excited with, because as customers move to containerization, they need this, right? So let's move to the next slide. So those of you who have seen this, I apologize, and we're redrawing or re-establishing the big picture for Azure Stack HCI. But truly, on the left side, you can see that Windows Admin Center gives us a powerful way to reach out to consume Azure services like monitor, file sync, update management, and so forth, right? But as time goes by, we are seeing increasing number of customers even using services like Azure Arc. From Azure, they are able to bring down Azure services to the on-prem environment like SQL Server, for example. Click next. So with Azure Stack HCI powering the solution using a myriad of different hardware brands and so forth, we can be contented, we can be excited as well to know that whether it's AKS or Azure Virtual Desktop is now truly within the midst of providing services from the edge all the way to cloud. Next. Now, just a little bit of a rewind, if you were in our sessions in the past. Truly, we are at the juncture where we can excite customers going from a 3-tier architecture on the left to a truly hyper-converged in an on-prem environment with native hybrid capabilities. So you could go from a single node, right, as mentioned, all the way to 16 nodes in a cluster, right? Now, these 16 nodes may sound like a limitation, but trust me, Microsoft didn't stop there. We can stitch together multiple 16 nodes if you want to take us to the biggest of thousands of nodes, just like how Azure gives us, right, availability groups and so forth, or availability zones. Now, coming back to the planet, keeping ourselves grounded, many of our customers told us that they like the 2 nodes design. They love the 4 nodes design as well. So it's not surprising that the #1 configuration happens to be 2 nodes and 4 nodes. In the distant third place, if you want, or second place, we have the 3 nodes. So if you look quickly into what customers ask for in the design elements is the number of fault domains, meaning the number of components that can fail. In the Azure Stack HCI design, if you want, we have the ability to have node failure. We can have the ability to tolerate drive failures. So each node itself is a fault domain. The drives are also fault domains, but we cannot forget that we also need CPUs and cores. All right, so number 4 being, next. Sorry, the animation is a bit out. All right, we have the first place sitting between second node and fourth node, and then a distant second place is the third node. But now with the single node, if you go to the next slide, we believe that the single node and the second node will probably become #1. And the second place goes to #4. So let's watch what happens in the next 12 to 24 months. We believe this forecasting, if you want, or prediction will come true, right? Together with needs that needs a lot of memory or small amount of memory, and of course, tiering and caching being another component of design element. Don't forget, Azure Stack HCI works off Azure subscription. And some of you may have heard that, oh, it costs $10 per core per month. But you know what? Customers of ours who have software assurance for Windows Server Data Center gets it for free. So that's exciting that how Microsoft bring value back into the solution. Now, don't forget, as mentioned earlier, many customers want a solution like this because of the capacity. What is the capacity that's available, right? So we can go into petabytes of available space, and providing the resiliency that Cole showed, even from a single node. Connectivity between the nodes is what we call the east-west, and connectivity from the users and as well as management, we call it north-south. Whether we go with switchless or with switch, these are all important components. Not forgetting having Active Directory to build together the single sign-on that Azure Stack HCI requires. And last but not least, we have Azure Arc to give us a secure multi-cloud management. Whether this cloud is on-premise from the customer perspective or cloud in Azure. Okay, so these are components that we're going to go into in more detail in the next half an hour. Tiering, caching, performance, resiliency as well. Next. Yep, you see the network adapters, you see the switchless. All this is all part of providing the performance and reliability. Okay, let's move to the next slide. Now, some of you may have seen the catalog, right? The HCI catalog and the sizing. So in this particular session, all right, I'm going to skip over the catalog and sizing because in the past we have done many a time to show it. So we're going to skip over this demo, but true to what the name says, the catalog gives you a listing of all the different hardware brands and so forth. Okay, and of course, the sizer gives us a way to piece together the solution, right? In terms of what are the workloads and so on. Okay, so click, all right, and we're going to skip over the demo, all right? Okay.
Before we get there, one more thing. I am going to need an extra digit.
I hear you.
Don't want to give anything away, but all right. Now we saw that we have these 300 Hyper-V virtual machines that are turned off. When we turn them on, each one is going to start running an open source Microsoft tool called disk speed to generate storage load. So, shall we start turning them on? Let's start with just the virtual machines on node 1. We'll bring those online, and what you'll see happen back in Windows Admin Center, and we can time-lapse forward here, is that you'll see the IOPS shoot through the tens and hundreds of thousands to 1 million 4K random IOPS serving just the virtual machines on node 1. This system isn't even breaking a sweat. Let's turn on some more virtual machines. Let's turn on the VMs on node 2. Now you'll see a pattern start to form here. These virtual machines are going to request another million IOPS, and they're going to get it, 2 million IOPS from this cluster. All right, I don't want to drag this out. Should we turn on all of the rest of the virtual machines? Let's turn them on from nodes 3 through 12 in kind of a sweep. Now, what we'll see here, as these virtual machines request more and more storage I/O, this hyper-converged cluster is able to satisfy it through 3, 4, 5 million IOPS to our previous record of 6 million IOPS, and continuing onward and upward through 7 million, 8 million, 9 million. Here's a big milestone, 10 million IOPS, 11, 12, 13 million IOPS from a single hyper-converged cluster. Folks, this is our new record, and we believe the industry record for any hyper-converged platform. The pace of innovation here is really exciting. In just 2 years, we can do twice as many IOPS, and last time it took us 16 servers. This time we only needed 12. Thank you, Cosmos!
Now, those of you who thought that video was exciting, just imagine being in the audience physically in that event. I was very grateful to be able to join that event back in 2018 with 12 nodes giving us that kind of IOPS. Just imagine what it would be like. Now, one of the things that we tried really hard at our own local level in this region was to demonstrate that performance really scales linearly through nodes. And like what Cosmos showed you, it does linearly scale one node at a time. So if you started with a single node and you were able to get, say, 700,000 IOPS, and it's very real to be able to get 700,000, I think a second node will give us close to 14,000, what I call 1.4 million. And then you add another one, you get another 700,000 and so forth. So 2 nodes to 3 nodes to 4 nodes is very real from a scaling perspective to get performance. The more nodes, the faster it gets, right? So click. Now, how do we achieve this, right? Some of you might be thinking, especially those of you who are new to this solution, the fastest way to understand it and the easiest way is probably through the cache. The cache is the fastest device within each node. And in order for this solution to work, every node in the cluster must use the same device for cache. So you can use persistent memory, you can use NVMe, you can use SSD as your cache. Now, Intel Optane DC persistent memory is not new. It's been around for a long time. In fact, from our perspective, even the Intel Optane NVMe, or what is known as the DC SSD, the data center SSD. Now, some of you may be thinking, but isn't it true that maybe some of this technology is not going to be around with us for the next 12, 24 months? But the point here is the solution itself will work through technology, even from the hardware perspective, in terms of its availability. As the technology landscape shifts from certain device type to other device type, we will be able to consistently harness the performance. So regardless of whether this was a recent past, whether this is going to be the present or into the future, we can be assured that whether it's SSD, NVMe, or persistent memory, we will be able to get very fast performance. And that's the power of being able to get performance through caching. But you cannot use the normal, humble spindle drive for caching purposes. Next. So if you're to do SSD, let's do it correctly. So these are some of the, lessons and learnings that Microsoft has put into the Microsoft learning website. So to summarize that, if you want, click. We have actually put down a list of the capabilities. SSDs for cache, you need to be using mixed use. That's the common language. But what does mixed use mean from a technical perspective? There is this terminology called drive write per day, DWPD. It needs to be 3 and above. Now, some of the proposals we have seen, people were putting in the wrong SSD for cache. They were using the read intense version, which has a drive write per day of less than 3. And part of the reason maybe is because they were trying to put in the most affordable solution, the cheapest solution. But we need to do it correctly. So can we use write intense? Some people ask. You can, but it will make the solution more expensive than necessary. So the ultimate solution really is to just use mixed use SSD. Next. So that's it. How do we benchmark this? So I got one of my good buddies, Linus, right? He went through the whole process, right? From GitHub, he downloaded a tool called VM Fleet. And if you click to the next screen, there's a tool called this SPD. This SPD will run, all right, in each virtual machine, and VM Fleet will be the control center to talk to each one of the virtual machines and this SPD, and will roll out those results for you. So from some of our findings, if you are doing a 100% read and 0% write with 2 nodes, we can get about 560,000 from this run. In a separate run, click, we were able to get 555,000. So what we do is you do multiple runs of each configuration, like in this case, read 100%, write 0%, and then we do an average of the results. Okay, and this particular benchmark was done with a machine with 2 CPU, 256 gig of RAM, and 1 375 gig Intel Optane NVMe, just for your information. So depending on the hardware config, you get different results. So if we take that further, and we did it with 80% read and write 20%, you notice the performance dropped to 363,000. It's not surprising because now we are doing a lot more writing. We write even further. In the next screenshot, you notice it dropped even further. It's gone down to 334. It just shows that as the load increases, like a very heavy SQL server, the system is holding the performance at least with 300,000+ IOPS from the earlier 500,000. So this is a solution that consistently can hold performance to the user's expectation. Now, behind the scenes, some of you may have heard that there's this thing called switchless and switch configuration. A lot of these is due to how we connect the nodes together. We use a technology called RDMA. And RDMA itself uses 2 different protocols. One is called Rocky version 2, and the other one is IWAP. Regardless of which one, we still can consistently get very, very good data throughput. The IOPS will increase, and the latency for writing the data will drop. And subsequent to that, because the RDMA network adapters have its own CPU to process the data, right? The CPU inside each node can be allocated more to running virtual machines. So this is how we give back the performance of the nodes to virtual machines rather than it being consumed for the purpose of transferring data from one node to another. So next. Now, some of us probably could have read that, you know what, we can do switchless with 2 nodes, 3 nodes, maybe even 4 nodes. Now, the switch that you see in that, right, in this particular drawing is for a switch design. So the switch is to hook together all the nodes for east-west, right, switch 1 and switch 2. Okay, if we go to the next slide, we will be able to see that in the actual network design, how the network interfaces themselves are connected together. So I know they're a bit small. Apologize for that. So we have the link in the slide to take you further. Right? For those of you interested to learn more, the Microsoft Learning site is definitely the best. Right? So we need the RDMA NICs on each node in order to talk through. Next. Now, if you go to a switchless configuration, now you notice that the switches are missing. In place of that, we have 2 connections from each node to talk to each other. Right, so node 1, we have 2 connections talking to node 2, and similarly to node 3, and so forth. Right, if you go to the next slide, Cole, you'll be able to see how we actually connect all of them together. The RDMA NICs now is connected to each other. They're no longer connected to the top of the rack switch, like what the switch configuration looks like. Right, so next. There are underlying strength to the protocol that makes this possible. The switchless configuration really takes advantage of two specific protocols. One is SMB direct and the other one is SMB multi-channel. So with SMB multi-channel, it detects the RDMA capabilities of the NIC, and immediately because it's using RDMA, SMB direct is enabled. So therefore, the connections between the two, because there are two, it will aggregate both together. So if it's 25 gig on one line and 25 gig on the other line, it will combine the two together to give you 50 gig. So next slide, please. So these are capabilities of the underlying protocol. So the benefit of SMB multi-channel is truly very powerful. This gives us that performance that you see when we add additional nodes that we talked about. All right, so it's very important for us to realize that that capability also gives us fault tolerance to the network connection. Because if one network cable somehow is not working or functioning correctly, it will be able to continue running on the remaining network with some performance impact, right? But you can be assured that that varies depending on the amount of data that's being written. So this automatic configuration capability is done by design. So SMB multi-channel also is a feature that is turned on automatically. Right, so that's the exciting part about a solution that is made so easy. This is what some of the cabling looks like, right? For those of you interested, all right, we have the DAC cable on the left, we've got a fiber channel patch cord on the right, all right, the bluish color tinge cable. Next. And of course, what we wanted to do next was to show you through some diagrams what the switchless configuration looks like. Let's go, Carl. Thank you. So as you can see, this is a two node. So in a single link scenario, which is not the supported is dual link. All you have to do is have a subnet to connect those two together. Next. Okay. And then when you add on additional nodes, obviously there will be additional cables that will be connected. So click through. Yeah, let's click through. Yeah. And then when we go to a 4-node, you see all the different subnetting and every node connecting to each other. Now, this is something that a lot of people tend to ask for. How do you connect them all together? There's no magic. It's through TCP/IP, through the simple subnetting capability of each network achieves that purpose. And Linus and I, over the years, have also experimented taking switchless to 5 nodes, and we were successful in one of the events that we did back in early 2020. Just before the lockdown took place. Next. Now, cluster witness, we can't go into a lot of details, but be assured that we have a reliable way to do it. In a very small environment, we can use a USB thumb drive, but most deployments will use a file share. And some of the bigger deployments, like the stretch clusters and so forth, we will use the Azure Cloud Witness. Next. Now, those of you who have for the longest time wondered how Azure Stack HCI can have redundancy, right? So we have the capacity with dynamic binding, right? And we have the ability through server and drive losses. So what Ko showed you earlier was a drive loss. We also have the ability to do server loss. And we want to take them through with you how some of the scenarios of a single node failure, for example, in a 2-node scenario. Next. Now, the dynamic binding capability is very unique, right? From a capacity scaling, we can just add additional drives. That's on the left. On the right side, if you have cache failure, the drives will all then report to the remaining cache. So this is how we provide a very powerful solution to keep performance going and the storage capacity running, even when there are failures. Next. Right now, those of you who have always wondered, how do we ensure resiliency? We have the 2-node scenario with two-way mirror, but we also have nested, right? In the 3-node, we do 3-way mirror, but the 2-way mirror is not available through Windows Admin Center. We'll show you some of that shortly. Next. Right now, as mentioned, we have the single node, right? So if you click through, right? How do we provide an understanding of resiliency from the single node? So as mentioned, we have the volume with two-way mirrors. That's how Cole was able to have a drive failure, and then by adding a replacement to the drive, he was able to keep that going. Next. And of course, when you add a second node, for example, so we have a two node. So what are the level of resiliency we get with two nodes? With two nodes, we have the additional nested resiliency, whereby we can have two drives fail, one on each node, and we can have one node go down and one drive fail in the remaining node. So all that is done through what we call nested resiliency. And we have the nested two-way mirror, click, and we have the nested mirror accelerated parity. Regardless of which one, we provide two fault domains at the node level and at the drive level. Okay, so that's the powerful part of nested resiliency for you. So we have three ways of how we can provide resiliency. Click. Okay. So we have the nested two-way, we have the nested mirror accelerated parity, and we have the two-way mirror. Next. So what happens when we go to Windows Admin Center and we look at the user interface? We see these three options. Okay, so we wanted to show you this so that you find it easier to understand from the logical design down to the actual user interface itself. Next. So what happens in a three node? We can tolerate two nodes failure. That's the beauty of this particular solution. Next. So from a storage pool perspective, how does that work out? So we actually have two options, as mentioned. We have the three-way mirror and we have the two-way mirror, but the two-way mirror, guess what? You can't see that in Windows Admin Center. Next. So you think we wanted to show you that as much as we want to? As you can see in Windows Admin Center, you can only see the three-way mirror. Next. So how about four nodes and bigger? So what are the different resiliency and configuration that we need? So as you can see, this shows a table highlighting when you need witnesses and so forth. So we're going to let you read through into this more as you go deeper. In this particular session, we're just going to jump over it briefly. But it's important to know that there are configurations which are better, and the better ones are the one with the witness. Always the case, even for the bigger four nodes and beyond. Now, if we go to the four node from a resiliency perspective, we're going to see two options. Volumes with mirror accelerated parity and volumes with three-way mirror. So how does that look from Windows Admin Center? As you can see, there are two options there that you will be able to choose when you're configuring for the four node resiliency and bigger. So it can be five node and so on. But when you select mirror accelerated parity, there are actually three options, right? Because the percentage of mirror can be changed from 10 to 20 to 30% at the beginning. So when you're selecting your three options, okay, and the corresponding parity to go with it. Next. So that's the power of the four-way mirror. Now, for the interest of time, Cole, I think we might have to skip this. All right, we will continue to go through as much as we can because I just realized due to the time loss earlier, we might be running short of time. All right,
Sure,
thank
no
you, Cole. Now, from a patch management perspective, you saw performance, you saw resiliency. We also need to patch regularly. I'm sure some of you know that last week or the week before, we actually had Patch Tuesday, right? So Patch Tuesday requires a solution like Windows Server Update Service, WSUS for short, to do the patching. Next. How do we do that in a holistic sense, if you want? All right. Now, many of you may have used it for Windows Server in the past, or even Windows Client like 11 and 10 and so on, and even earlier. Now, we are also able to do that with Azure Stack HCI. Next. So how do we deploy this? As you can see, this particular diagram shows the WSUS behind the firewall. Okay, the wall, if you want, right in the middle. But for larger organizations, they may put two WSUS servers, one in what we call the DMZ between the firewalls and one inside the network to provide a way to reduce the number of ports and the opening to the external firewall and to the internal service. Next. Now, another aspect of patching that we need to be aware of is called cluster-aware update. So within Azure Stack HCI, there are components within the cluster, the operating system itself, that needs to be patched. So there's a technology built in called cluster-aware update. And with this particular technology, we can be assured that the orchestration of patching of each node is done in a logical, in a well-controlled manner to ensure that all the workloads running in the virtual machines continue to work well with no downtime. Okay, see, these are some of the screens even within our environment that we capture for the purpose of demos as well as for training. On the left, we have the Windows Update Cluster Aware Update approach with Windows Admin Center, but we also have the Failover Cluster Manager, which some of you may be familiar with. We strongly recommend that you use the Windows Admin Center approach with Azure Stack HCI OS. Next. It's okay, Ko. All good. Now, one of the nice things with Cluster Aware Update with Windows Azure Stack HCI is the fact that you can merge in hardware updates. So we captured a few screens for the purpose of time saving, because we do have demos that we can show, but so that we can get it all the way to the end, to the even the DRPs that we want to run through at the end. So next, go. Now, those of you who have not seen this, this is truly exciting when it comes to patching, right? And the patching is known as hot patch. Windows Server 2022 Data Center has come up with a new edition called the Azure Edition. So let's roll the demo for our audiences. Go.
Hot patching is a new way to install updates that doesn't require a reboot and won't interrupt workloads running on your server. Before we start, let me describe the demo environment. On the right side, I have a new Windows Server 2022 Azure Edition Core VM created with Azure Auto Manage, where I'm going to manually install hot patch updates. Now, for comparison, on the left side, I have a traditional Windows Server 2022 Core VM, and I will install a comparable latest cumulative update, or an LCU. This is a traditional update. Now, on each VM, I've queued up 2 massive file copies as sample workloads. Now, on top, there's a timer so we can track the status of the patching installation. I'm going to start off the patch installation on each VM. First, the traditional LCU. I'm going to give it a little bit of a head start. You can see it's going ahead and it's starting on the left-hand side. Next, we're going to switch on over to the right-hand side and do the hot patch update. Now, the hot patch, oh, I hope you didn't blink. You may have missed it. It's done. I feel kind of bad about that. As you can see, the file copy continued uninterrupted. And you can see the traditional cumulative update, the LCU on the left-hand side, is still going. You know, in case you missed the first hot patch, let's run a second hot patch. So we're going to go ahead and install a second one. Look closely, don't blink. And you can see, here we go, the second hot patch. And that one's done, just like that. And you can see that was done again without impacting the running workload. Now, one of the great advantages of hot patches is that the changes are made in memory. This means that even running processes will pick up the new updates immediately and without interruption. Now, we installed these updates manually for the demo so you can see just how impactful this technology is. In reality, I would use the update orchestration and management tools developed for hot patching in Azure Auto Manage. Now, the left-hand side is still chugging along, so let's go ahead and speed up the video so we can get to the completion of the traditional update. You can see at 7 minutes and 12 seconds, we're finally done, but it requires a reboot to complete the update process. If I reboot right now, it's going to interrupt my file copy. So I'm going to wait for the file copy to finish on up. So let's go ahead and speed to the end of that. And now we can perform the reboot. So that's a quick demo of what Azure Auto Manage and Windows Server 2022 Azure Edition can provide with hot patching and, of course, with Azure Stack HCI on premises.
Thank you, Jeff. That was a very exciting demo. Every time I see it, I get so thrilled. Now, the last portion that we wanted to end this session with truly must be disaster readiness. So built into Microsoft solution, we have great capability like stretch cluster and so forth. But not limited to that, we also have DR stretching from the edge all the way to cloud, like Azure File Sync, we have Azure Backup, we have Azure Site Recovery. Let's zoom in a little bit into the built-in stretch cluster. Now, as you can see from this diagram, we have Kuala Lumpur on the left and we have Singapore on the right. We get the ability to automatically fail over. And in the underlying storage, we use storage replica as the technology to make that possible. Now, some of you must be wondering, what is the minimum starting point for Azure Stack HCI stretch cluster? 4 nodes, 2 nodes in each location. Now, a question popped in about a year and a half, 2 years ago, possibly. What if I only had the money to buy 2 nodes to start with? Can I add the 2 nodes later? The answer is yes. So the second link at the bottom that says convert to a stretch cluster, all right, is where you can start with 2 nodes and then later on add another 2 nodes in the remote side so that it can fail over. Next. So it's important for us to understand the solution isn't just powerful, it's flexible. You can go with an active-active scenario, right, on the left, right? Or you can go with an active-passive design on the right, whereby on the left side of that particular diagram, you have the active, which means all the VMs are running, but on the right side, the VMs are not running. So in the case of one side going down, the remote side comes alive. But in an active, both sides are running, depending on what workload that is. We have that flexibility with stretch cluster. Next. All right, so that kind of takes us to the almost to the end, if you want. So in order to summarize, hopefully this session has given you an insight, if you want, on how we can work with great technology like persistent memory down to NVMe to SSD and spindle drive. All right, and of course the RDMA stitching between the nodes, giving us a powerful set of components for an amazing performing, reliable, with the ability to patch regularly, consistently, with technology like WSUS, cluster aware update, and even from a DR perspective with stretch cluster. Now, some of us probably worried, you know what? I've seen some exciting capabilities here. What more can I do? In a session like this is all we can show you, but we want to assure you that running VMs on these servers in your premises give us a whole host of services, not just running virtual machines with Windows Server, with Windows Client, or open source. We have all these Azure PaaS services and more available for you. And not forgetting, with Windows Admin Center, we can reach outwards. So this is going to the cloud if you want, while workloads are running on-premise. Right? So services like Azure Backup, Azure Site Recovery, Azure File Sync, Azure Update Management, Azure Monitor, and so on and so on and so on. And some of you are probably already aware that there's so many hundreds of services on Azure that customers can consume from on-prem. Windows Admin Center facilitates many of these. And of course, from Azure Arc, we can come down. Okay, that's the power of bringing cloud together from edge to cloud, cloud down back to edge and the data center. Next. All right, so that's it. We want to be able to take you through more, right? But time has come to an end if you want, right? We look forward to seeing you next month, all right, on the last Monday at the same time in Tech Talks Asia. And don't forget, today was session 1. Next month, we have session 2, right? We are excited to bring you the ability to do more with less using Azure Stack HCI, right? Not limited to all the stuff, because as the month inches towards the end of support for Windows Server 2012, 2012 and we have just gone past SQL Server the last few months, we want to make sure that you're truly protected. We wanted to elevate all of those capabilities that are available. Next. Questions, please drop them into the YouTube live, right? And those of you who are on the team session with us, drop us the questions in chat. But we're very excited and very privileged to be here to help you understand the technology better. On behalf of the team, Cole, Vic, Lorraine, and myself, we want to give you all the thanks and blessings for the rest of the day. And thank you for staying with us for this 1 hour session. And apologize for some of the hiccups that we had from a technical perspective. And those of you who are interested to learn more about security, we want to invite you to our Security 101 group. So the QR code is there, and it's a WhatsApp chat group that I manage together with my team. And we want to empower you to be protected ultimately, because there are just so much disasters out there from a cyber threat perspective. We want you to be protected. Any more? Let's see, Cole. You can take it all the way to the end if there are any other slides.
Yeah, it's end of the slide already.
Okay. So pretty much that takes us to the end. Thank you, everyone. It's 2 o'clock on the dot. All right. We're going to give you this blessing that the rest of the week is going to be amazing. And if there are any questions, please do not hesitate to come back to us. Thank you, everyone. Back to you, Vic. See you
Thank
again
you.
till next
Bye.
month.
See you again next month. Thank
Bye,
you.
everyone.
Bye. Okay. Vic, you can stop streaming.
Stop already. No worries.
Stop
Okay.
already, yeah.
Good
Okay.
job. Good job.
Good job. It's only
Thank you,
the
everyone.
beginning.
Sorry.
It's only the beginning. The voice was not so good, and then especially the music part. That one was not audible.
Yeah, it was.
But then on the streaming side, when once it's streaming, Noel's voice was not as bad as we are encountering in the Teams here.
Yeah.
Yeah, the streaming part was okay. The voice came out good. Not that much of this kind of the all those disturbances.
Yeah, the G3. Yeah, I know. But the problem is actually on my side. For some reason, I think when I unplugged the Jabra and put it over to my what I call my other laptop, all right, the connection wasn't very good. I think it's the USB port. Thank you, everyone. Thank you so much. Thanks, Linus. Thanks for joining us. So sorry, this session could have been better. In fact, I think we also so much. We didn't have such technical issues.
I was thinking, do you want to do pre-recorded and stream later, or you really want to do it live?
Good question, Linus. I think there are two thinking around that. One is the team wants us to do as much of it live as possible, but of course, from a demo perspective, we do use a lot of pre-recorded content. But if you're saying recording the whole thing, what I call earlier, and then just playing it back, it's something that we can consider because we have 2 additional bonus sessions that we need to do. That may be the sessions that we can use this pre-recorded approach, Linus.
Yeah, because the pre-record will remove some of the live stream issue, like suddenly internet is not stable and so on and so forth. Because you are already live, you want to isolate that as much as you can. All right. So then with so many point of so many people involved, right, at different location, so the point of failure can be quite a few. Pre-recorded will eliminate audits, and during that moment you just need to play back. All right, whether if you are busy, you have event on, you have activities and all that, we can still run. It's just that we need people to answer questions, so at least if let's say somebody needs you to present on the last Monday of the month and you can't be turning it away, all right, it could be something important. All right.
Great.
So then that will actually give you a better position, and then the process is already in place. I mean, that's just what I came across. Because,
I can schedule it to podcast at a certain time.
We just tabulate to broadcast, and that is the live stream. I have seen even Microsoft. I've seen their an online sessions, right? They are not live session. They are pre-recorded.
Yeah, you can schedule for later.
So they prepare everything as if it is live, all right, but they stream it and broadcast at a specific time. That can actually eliminate a lot of unknown.
Yep, totally agree with you, Linus. It's an awesome point. All right.
And Michelle put some suggestion in the chat.
Yep.
Yeah, or should. You know what? Michelle and Malcolm or both was supposed to start the session, and you
Yep.
jumped in and didn't give them a chance.
Oh yeah.
Yeah. Oh, we were so overzealous. To get going, we totally forgot the
No,
plan.
because of the slight challenge that we had
Yep.
on the slides, so that's why we took a bit of our time and took
Yep.
us about a bit off balance. Yeah.
Oh shoot. Never mind. Never mind. I will take the blame for this, and I will explain to her what happened. But thank you so much, team. Thank you for holding it together. Cole, sorry.
Well, my suggestion is to, before any session that you start, 1 hour before, check your Windows update or whatever. Then you might want to restart your laptop, or you notice the syncing is heavy, and so on, because that will eliminate all the technical problem on the devices.
Yeah, agreed. But I don't know why. Even this morning session, everything was okay.
Yeah.
Right? And then when I tried to switch my PowerPoint, that's when I see the hourglass just keep going and going. And that's when I knew something wrong already.
It may have something to do with your internet speed though, because I noticed your voice was muffling and draggy.
During this session, I'm actually using Wi-Fi, but my other laptop is connected to the cable.
Yeah.
I don't think the problem
with Wi-Fi.
Yeah, this one I know why the problem, because of the Wi-Fi. That's why I went down the route of what Ko is doing on his side with cable. So actually, I have the cable wired already. Just that this particular system was having that problem with PowerPoint, so that's why I have to switch to this other laptop. All right. Yeah. So good point. Yeah, I should do this test at least half an hour, but because we do so many, right? So I just need to figure out why suddenly I had this problem. Okay.
Okay. Cool.
Thank you, everyone.
Thanks, everyone.
Again shortly. Okay, take care.
Thank you.
Thank
Bye.
you.
Oh, thank you.
Right, bye.
Linus, thank you.
Bye,
Bye-bye.
Michelle
Thanks,
and
bye.
Danny.